Hey, welcome to the shop. Today what we're going to talk about is the drill press. The drill press is a very versatile tool. Its specialty is putting holes in objects. Instead of using a hand drill all the time, you would use a drill like this to maybe make a 90-degree hole, which it would do very easily. We'll talk about the different components of the drill press in a second. The table will rotate, so it'll allow you to use these slots that are in the bottom. It'll also, and there's a lock underneath here, a twisty lock, and then you can also tilt it like this so that you can put holes in on angles. So we'll talk about that advanced move a little bit later. There's a lock in the back for the table, and you want to raise and lower this using the crank. Make sure the lock is off before you wind the table down. We've had many broken racks, which is the gear thing on the side here, that has been broken because people have locked it, not realized or haven't unlocked it, and they start cranking on it and they wonder why it's not going down. All right, so we have table, we have our stock that we want to put a hole in. Now the selection comes into what type of drill bit do we want? Man, or the human race, has tried to put different holes into different things since the Stone Age. And we've got quite the arsenal acquired now. So we have a spade bit, which is used a lot in woodworking, rough woodworking. We've got a Forstner bit, which is kind of cool. It's got a razor edge. We'll go into more depth in this a little bit later. It's got a point so you can lay out centers and put it exactly where you want. You got plug bits. So this will actually cut a little plug for a piece of wood. So if you're doing some Muskoka chairs or something like that and you want to hide the screws, you would actually put this in and cut a little plug for it, cut the opposing hole in the Muskoka chair, and then glue one in top of the other. It's kind of a neat way to hide stuff. But the most popular way is what they call a jobber drill. This is this particular drill can drill either metal or wood. And it's got flutes along here that aren't too steep and they're not too shallow. So the chips, as you cut them, will make their way easily to the surface. Sometimes what happens is you can actually break drills like this because you don't actually get that chip to come out and it'll actually bind in there and snap. So we don't want to have that happen. So there's two methods to clearing it out. One, select a drill that's got a long flute, if you have it. If not, as you're going in, what we do is we peck drill. And we'll talk about that more in depth in version 2.0 of using the drill press. But today we just want to go through the basics of what we should be looking for. So I'll put these away. And please put the tools back every time you use them. And find a spot where they look right and easy to find later. We're going to start with a new acronym for the shop. It's called SOC. Set up, operate, clean up, and keep it that way. So if we run with that, that'll be good. So this is a drill chuck. This was made late 1800s, early 1900s. By Jacob family. And they looked at the drill press before that, and it was a spindle and it had belts, and they went up through the ceiling and ran with a water wheel. That's how they powered everything. And they said, you know what? It's really a drag to go and put this into a piece of wood, try to put it on center and all the rest of it. Why don't we make something that makes it really easy to put it on, to put the drill or attachment in the drill press. That's how easy it is. So this chuck is a keyed chuck. This is what the key looks like. You put it in one of the three holes and you tighten. If the drill does slip on older chucks, there's three holes. I recommend that you actually use all three holes. This is a ring, if you would, and the things that actually engage on it. And if you tighten one side, it goes like this, and you tighten the other side, it goes like this. And if you tighten all three, it comes down and puts equal pressure all the way around. There's three jaws that are in here. If you do that, all three jaws have the same amount of stress on them. So that makes it easy to put in and out. When you're drilling a hole, don't add any more lightning holes to the table. Try to make sure that your drill is going to go through the center hole. That's why they manufacture it. Or what you could do is, if this was a big long piece, I could set this up maybe that I'm going to be way over here, and I'm going to put this guy in here, run him backwards. Yeah, that looks pretty good. I'll lock the table, and then I'll lock this rotation, and then I'll check it before I turn it on, and then I can drill something like that. Okay, always use guards on the table. They slide in like this. Make sure you're all set. All right, on off button, conventional. Now, it works powered up. I have the power on. It'll work with the main power on. You do not need the dust collector on for this one. So it works very well. So anytime you want to put in holes, it's a great addition. Now, there is an attachment that's just missing on this particular drill that would allow you to have it go down to a certain depth. So if you were doing a whole ring of holes along here, you could actually put a depth stop on it, screw it down. It would only allow the drill to go so far, and then that would allow you to drill everything. That's called peck drilling, just to make sure that the drill doesn't get all chewed up. Up top, we have belts. Belts control the speed. And you can see on the back there that there's a number of configurations. So you find the speed you want to use, and then what you would do is move the belts in accordance to line up what it says in the back chart there. The rule of thumb is, whatever, depending on what you're cutting, this dictates your speed and the diameter of your drill. So if this is super hard, not wood, say steel, you'll want to spin this thing slow enough that you can actually see the flutes as they turn. And we'll do this more in depth when we talk about speeds and feeds for drill bits. But basically that would be slow for something hard. For something soft like wood, aluminum, plastic, that sort of thing, you want to be able to be spinning very, very fast.